I'm doing it.
Now do it.
Meeting, BBA's October meeting is now in session. Our first report will be our vice president and the schedule.
Okay. Thank you. Thank you very much. All right. Of course, I didn't prepare this in advance. I got to go back and find it again. Let me see. All right. I'm looking for it. I'll find it. Let's see. Where are we? Oh, this is a YouTube thing and all that. Where's the other?
Don't mess up my YouTube thing.
Right. I won't. I just got to find Night Sky Network again. Where's that? Oh, here we go. Night Sky Network. All right. Now, this is the strangest thing. You can't go back in the calendar. You can't go backwards on the cell phone. But I think you can go back here. Calendar preferences, scheduled report, event. See the I don't want to schedule an event. Where's the calendar? I looked in events.
Joe,
Isn't it on the,
look at the black bar on
see where it
the
says
right
open
hand
items,
side.
just go up the left of that.
Switch to calendar view. Got it. Thank you. Okay. All right, now I can share. Now I can share. Ah. Minimize, minimize. Minimize. Okay, now I can share. All right. All right. Thank you for your patience. I am screen sharing. Something about okay. Okay, here we go. Today's the 3rd. Corn Watch tomorrow night. Can y'all see it okay? I can zoom in a little bit.
Yeah, it's good.
Okay. Night Watch on the Saturday, the 5th at Chip Oaks again. Here we go. 10th, Garden Stars and Europa Clipper launch window. What the heck is that?
It's where they're supposed to launch.
Europa Clipper? FYI. Okay.
The launch window opens. Hopefully they launch that day.
A part of this event, we're just observing.
Oh, we're observers. Okay. We got the Barry Art Museum at on Friday at 6. ODU Barry Art Museum again on the 12th. So that's a 2-day thing.
Thing disappeared.
Let's see. Saturday, Sunday, the 19th. Girl Scout event was canceled because I can't remember why. Churchland was canceled also. Skywatch Northwest River Park. I have a real treat for everybody. Tonight I'm going to do a presentation on Pluto. And the last picture I've got to present, which unfortunately I can't get to work for the Zoomies, is the one we took at Skywatch Northwest River Park last Saturday. Okay. Also, that can coincides with York River State Park the same day. All right. East Coast Star Party. That's the big one starting the 31st. And how many people are signed up? Not me yet, but I will. Here we go. RSVPs.
That'll be anyone's.
Well, where's the RSVPs?
7 yeses. That's not bad.
Oh, 7 yeses and 2 probablys. All right. And it's same price, $60, right?
Yeah, what the sheet says.
For the whole weekend.
Well, we have 17 people who have registered so far.
Oh, that's even better. Okay, so they didn't even RSVP. They said, here's my money.
That's how many people have paid money.
Right. Okay, very good. Let's see. Let me back up a little bit. Where's my backup thing? This thing's in the way, isn't it? Out of the way. Out of the way. All right. Okay. And the next month in November is the big one. Star Party Public Night. That's at East Coast Star Party at Chip Oaks. It's public night is Friday. Saturday and Sunday. I thought it goes to Sunday, doesn't it? It goes to Sunday morning. I'm sorry.
I'm sorry. I was thinking of something else.
It goes to Sunday morning, but
Yeah.
so it goes overnight. The Chip Oaks night watch.
That Kids in Grief thing scheduled. We're in Chip Oaks.
Yeah, I don't know. I must have done that. and I'll call them up and tell them we can't do it. Unless somebody wants to go to that too.
Are you sure the date is right?
Pretty sure. I'll check Kids in Grief. That was probably scheduled a long time ago. Because we went last year too.
When the Night Sky Network did that update, it doesn't show, remember how it used to show multi-day events as a line through them all? It doesn't do that
I
anymore.
know they fixed it for us, didn't they?
Yeah.
This Cub Scout event, they didn't tell us the location yet. So as soon as they do, I'll approve that Cub Scout event on Tuesday night. Then the following Thursday's a club meeting. This is November. Night Watch, Indian River High School. That'll be a fun event. That's the one they wanted to vet. They wanted to vet everybody. So I have to provide a list of names before you can get in there because they don't want any bad guys with their high school. Veterans Day 11th. So that's a big holiday for our school guys, I think. Saturday, Sundays, Girl Scout camping trip is also on the 16th. And I think we can probably do both of those things. One's in the during the day and one's at night. Stargazing at FS Beach. Where is that? Fort Story Beach, right? That's on the 22nd. Skywatch Northwest River Park, the 23rd. And then after Thanksgiving, Corn Watch and Back Bay Holiday Luncheon, which everybody should have gotten an announcement. If you didn't, let me know. Because every club member should have got the announcement on by email.
Is that date right?
That date is right.
We were late getting our reservation in, couldn't get it.
Yeah, I couldn't get a Saturday
Oh, okay.
at anywhere. And this one place, Gus and George's, which is very good. It's not expensive. And we should probably fill up that room with 30. I think it holds 30. So I'm sure we'll fill up that room. And they got very reasonable prices too. Did I say that? Okay. Any questions on the events? I do want to mention a couple things about the Astronomical League when it's your turn to do. Who's ever turn? Bruce is not here.
No,
Bruce is not gonna be here.
Bruce is not going to be here.
He's upset, right?
All right. Well, while I'm here, the Astronomical League does have the Blaze Star, that's T Corona Borealis award. And you can get that. Let me see, maybe I can go to it real quick and show everybody. I don't know exactly what you have to do. I've been taking pictures of it, and Rich has confirmed some of the magnitudes and everything, so he's a lot better than I am about that. So I'll continue to take pictures, and we'll try to watch the magnitude and compare it with the other stars nearby. And eventually it's going to go to second magnitude sometime in October, we hope. Isn't that right, Rich? You can confirm all this.
Well, the prediction based on it entering the pre-eruption dip that we've seen in the past was between April and September of this year. So
that
STAR is not cooperating with our prediction.
okay. I thought it was September, October. All righty.
Yeah, we thought it was going to go again already, which would have been nice because Corona Borealis is getting pretty low in the sky in the evening. So
Yeah, it's getting
would
harder
have
and
been
harder.
nice, like, a few months ago would have been.
I hope somebody gets to see it.
Yeah.
All right, that's all I got. Thank you very much.
I'll make one comment since you mentioned it was on the calendar for the launch window opening of the Europa Clipper.
Yeah.
If you haven't checked out, but Night Sky Network on their YouTube channel, I know that there was an email that was sent out about a webinar about the science mission of the Europa Clipper. It was one of the principal scientists for NASA was explaining the mission. It wasn't really much about the spacecraft itself as much as why we're going to Europa, what they're trying to discover there. And it was very interesting. So it is on there. If you subscribe to the Night Sky Network's YouTube channel, there is a lot of good content on there. But it was a pretty interesting watch.
Very good. Thank you. I will subscribe myself.
I was bummed out though, because one of the things originally they wanted to do was to actually send a lander down to drill into the ice sheet. And apparently that got axed out for budget.
Yeah.
We can send
Yeah,
a
on the webinar. I didn't know that got axed.
Boeing spacecraft up there and let them do it. Let it be a man mission.
Yeah, they'll probably go back, but this one's just doing a bunch of flybys.
This bottom part again right here.
Okay, thank you, Vice President. Thank you for the schedule. And now it's time for the treasurer's report. Go ahead, Treasurer Rich.
He's waiting for somebody to move that we dispense with them.
Bring up spreadsheets. All right, so we got a good amount of money, 11,640 across all of our accounts. And we've paid out our scholarship for the year, and we almost are pretty well funded for next year. So we're in a good spot on scholarships. We are good on expenses. The delta for the month was only we're down like $32 from the previous month. We didn't have a lot of expenses. The big one was we reimbursed Bruce, because Bruce bought all the raffle tickets for East Coast Star Party. And that was $650. So Bruce didn't get to spend $650 on trinkets for himself. They're all raffle prizes for East Coast Star Party. And it was balanced out by mainly a lot of registrations that we got for East Coast Star Party. We've currently brought in $1,300, have 17 registrations for East Coast Star Party. So we're looking at we probably need 5 or 6 more. The last 2, our expenses were about $2,000. The expenses will be a little less this time because on the other ones we bought stuff that we can reuse, like the red lights and things like that, as well as now Sean has his master plan for t-shirts, which probably save us $100 or $200. But yeah, we definitely need a couple more registrations. 5 or 6 more would put us in a good spot. And based on people I know we're going to go and haven't signed up yet, I don't think that's going to be a problem. We gained 5 new members over the course of the month, which brings us up to 201. That's all I got, unless anyone has any further questions.
Any questions for the treasurer?
We will spend money next month because we're going to start having to pay for porta potties and East Coast Star Party stuff. But we'll still be fine. We're in a good spot.
Do we have a motion to approve the treasurer's report? It's been moved. A second?
Second.
What happens if you don't?
Moved and seconded. All in favor, say aye.
Aye.
Opposed, nay.
I'm not
Treasurer's
using this.
is approved. Secretary's report.
I motion that we dispense with the secretary's report.
Is there a second?
Second.
All in favor?
Aye.
Okay, we're not gonna have secretaries read the minutes.
Go to the Back Bay YouTube channel and you can rewatch it. You don't need.
Yeah, unfortunately, I haven't even seen the minutes from last month. Usually he sends them to me, but I didn't, for some reason, they didn't come to my email, so I'll have to read it separately. Okay, old business. Well, let me admit I dropped the ball. I was supposed to form a committee to start looking for some possible candidates for election of officers coming up in November, president and secretary, and I didn't. So I've asked Jeremy if he would be so kind as to form a committee within the next few weeks, days. We only have another month. Next month is the election of officers. So do some research to see if do we have any volunteers who want to be the club president? It's not that hard. And we need some new blood because my blood is pretty old.
So if I can't run, I'll do it. I'll chair the committee.
Well, he's chairing the committee, but you're going to be a member.
I'll be a member.
And you're going to be a member.
We got more committee members than we got candidates.
Well, maybe some of the committee members can be a candidate. Okay,
Who's interested? Happy to discuss that.
yes, if there's anybody interested, of course, there's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 people plus me in the meeting. So out of 200 people, we can't get.
Where's everybody? We had a full room last week.
We had a good crowd last week, but last month.
I think the global war is affecting us.
Yeah.
People are at Staunton River.
Yeah, there's people signing up.
That's true, that's true, that's right. Okay, including, speaking of star parties, another old business item is the East Coast Star Party. And I've got a flyer here. Did anyone not get the flyer? Raise your hand if you didn't get it.
Raise your hand if you're not here.
Raise your hand if you're not here. Made 30 copies. There's.
Why did I haven't added, what about fee and scholarship?
We'll get to that.
Already. Oh, not RRT and scholarship. Okay, check.
Okay. Okay, the East Coast Star Party will be starting the 31st of October, running through Sunday, which is what, the 4th? 3rd? Okay, yeah, the 3rd. It's Thursday is the 31st, Friday is the 1st, Saturday is the 2nd, Sunday is the 3rd. We hopefully will have good weather. Friday, the 1st will be the night that the public is invited, and hopefully we'll have a good crowd. And if it's poor weather, Bruce will be prepared to do a presentation under the shelter over at the conference center. Okay, let me mention what the door prize is tonight. Did everybody get a red door prize ticket?
The odds are much better here.
Sorry for you guys out in Zoom land, you don't get a door prize. It's a nice,
It's a new car.
it's a great little book called The Deep Sky Observer's Year. I mean, this is a neat book. I glanced through it, and it's a lot of good stuff on there about basic astronomy resources. Plus the back half is the night sky month by month. What objects are up in the sky every month? And it's got not just a list, but it talks a little bit about them. It shows sketches of the constellation. So this will be the door prize. I'm gradually lowering my library at home. My wife wants me to get rid of some stuff, and I'm trying to do that. Okay, we've got our scholarship chairman here. Is there anything to report on the scholarship situation?
So we got confirmation that the city of Virginia Beach has funded $2,800 for 2025
Okay,
for the Nick Anderson scholarship, and so looks like we're going to be able to repeat the $1,500 Back Bay Amateur Astronomers and $1,000 for the Georgia June Memorial Scholarship. So we're handing out 2, 3, 4, almost $5,000+ here for our size organization, which is absolutely an incredible achievement.
well, with the size of our treasury, we might be able to even augment that.
Yeah.
So that'll be
Yeah.
up for
So, and we'll set that probably in January, once everything settles out.
after.
Our great treasurer, Rich Roberts, can give us a total of everything, and then we'll go from there.
Okay,
George,
And-
while we're talking about scholarships, it's probably a good time to discuss the George June raffle prize. So we're not rushing.
Oh, yeah, we got something.
oh, no, we have to decide what to
Bye.
do. We've got a telescope, don't we?
We do, we got donated a Star Sense telescope, so we have one that was donated, I just picked it up. And
Describe a
she's
star.
in the room with us, the guy who donated, so we thank you very much.
What's the Star Sense telescope? What's describe?
It's a 114 EQ Star Sense.
Reflector equatorial mount,
Yeah, equatorial mount.
114 mm.
So if we wanted to augment Georgia June raffle, like we did that one time where we had 2 prizes, we do have a beginner telescope right now. So, what do you guys? Excellent.
How about an eyepiece filter kit?
Or even like a zoom eyepiece, if you
Oh,
want
that's
that,
nice, yeah.
because
That's
those are good for amateurs.
that and a Barlow, and you're good to go.
Yeah.
That sounds good.
Yeah, all right.
Okay.
Mm,
Is there any news on the RRRT?
Did you want me to purchase these things?
Oh, yes,
Or
yes.
you gotta make a motion, or
Okay,
you're just gonna do it? I got a credit
Make an
card.
executive decision. I'll do just like the president. I'll make an executive decision. Go ahead and buy a Barlow and a Zoom eyepiece. A good Zoom eyepiece is made by Celestron. I've got one of their older models. I don't know if
Well,
they.
I'm not gonna go through it, right?
I know. I know. Sorry about that. I wish.
I
Ooh,
wish too.
ooh.
What happened, all right?
They went out of
They went out
business.
of business.
Okay. It got bought out. I thought it got bought out.
They disappeared.
So they're gone.
They're gone.
Maybe the other stuff didn't get picked up by Astro somebody down there? I thought they were.
Well, the website's down.
Yeah, in fact, there was a post on Facebook where someone posted a phone number, you contact out Orion in California there to get your equipment that you sent to them to fix.
Oh my
So you get it back.
gosh, oh, for goodness sakes.
So
Okay. All right. Is there anything going on with the RRRT? Ben?
No, I have no update on that.
Okay. All right. How about observing reports? Anybody seeing anything? Gabriel.
Yep, those of us who were at Fallscape State Park, not last weekend, but 2 weekends ago. Ride there was a bit of a pain because we had to ride in the tram with all of our stuff, but we were able to like get them there. And for about 90 minutes, it was great seeing. I had one of my best views of the Sagittarius nebulas I've ever had. M17 in particular, you can see the entire horseshoe shape that the Gauss forms, is why it's called the Omega Nebula as well. That was the first time I had seen it before.
All right. Yeah, we had a good night. That's a beautiful spot out there at Falls Cape. Did you want to say anything about that, John?
Well, just that Tammy in the park, the ranger, I can't think of her name now, but they were just ecstatic that we showed up and they had so many scopes and so much knowledge, and it was everybody enjoyed themselves and they were really great.
Yeah, John's wife Tammy is a volunteer at Falls Cape and takes some people on tours and things, and she was a wonderful hostess. Any other observing reports? The last Saturday, Jeff Goldstein and Roland Downing and the brand new member, Soham, I can't pronounce his last name, were there. We were at ODU. ODU had a Rain in Science event with, there must have been 40 or so tables of people of the different science orientation, eco-science, environmental, water, power, things like that. And we showed people sunspots on the sun. And I counted over 200 people came through our telescopes, and might have missed some, but it was a wonderful event. And some people were really inspired to see sunspots and found out what sunspots really are. Any other observing reports?
This may fall under the line, but anybody see the news this morning? They had film clips of the solar eclipse in the southern hemisphere.
Oh,
And
yeah.
it wasn't a complete, so you had the ring of fire.
Oh, yeah. I didn't see that. Yeah, we missed that solar eclipse. That was in the southern hemisphere. An annular eclipse, the ring of fire.
George and I got in trouble with the police at the Saturday.
Oh,
Not really. Well,
They were two of our best participants.
yes, two Saturdays ago at our Saturday Sunday at the Elizabeth River Park, two state park police, maritime police showed up, and they wondered what we were doing, and we got to show them the sun and sunspots, and they were enthusiastic about it too. Thanks, Tom.
I think we only had, what, 4 people? Two of those guys were.
Actually, I think we ended up with 12.
12? Yeah.
Yeah,
before I showed up.
Yeah, there were some that came before you were there. Yes. Yeah, we had about 12 people at Elizabeth River Park, which is not too bad. It's on a day when they're having picnics. We sometimes get a lot more, but there were no picnics that day.
And just to add for that Fallscape State Park, if any of you guys get a chance to go do that event, take a light telescope and go, because that is some of the best skies here in this area, without a doubt. So dark. You can easily see the Milky Way. Just
Oh,
looking
yeah.
out, easily.
Yeah.
I really had an eye-opening experience looking through, the 10-inch dials. That's, I didn't realize how much that focal length makes. That
Sure.
focal, the ratio makes a difference. You know, there's 4.6 or something, 4.5. Mine's an F10, and so, you know, it's really not that bright. And your stuff is just over the top. Really good.
What size scope do you have?
I have a 10-inch.
10-inch?
10-inch thick aspirin. And a 6, and what I brought there was a 6, which I could not get to align.
Right.
But guess what? I finally opened the manual. That I haven't done in 20 years.
Well, when all else fails, read the manual.
It doesn't have a manual, so you can manually align it, so next time, I'll have it at the start party, so.
Now, you mentioned you got a 10-inch SCT. Well, that's got a long focal length. You'll have a narrow field of view, so it'll magnify a lot, but like you said, won't be as bright.
That's not as bright, no, I know, I mean, just the 6 to the 10 is a huge difference, but then looking through yours, wow. I mean, it's like looking at a book, you know, seeing the pictures.
When I first started out in astronomy 24 years ago, I had a little 90mm refractor, similar to the one I use for outreach now. And after about a year, I got aperture fever. And one of our other members was upgrading to a 6-inch refractor, but he had to sell his 8-inch Dob. So I bought his 8-inch Dob and his Dobsonian reflector. And I used that for a couple of years. And then I got aperture fever again when I considered that a 10-inch has more than 40% more light gathering power. And so I sold my 8-inch and put that money toward the 10-inch.
I love the 10-inch, it's too much for one.
Yeah, 10-inch SCT is a
I
heavy thing.
Lots of glass.
Is that a snowstorm yet?
Me.
I mean, okay, yeah.
Meads are even heavier.
Heavy glass.
Mead's in trouble now because Orion bought Mead, so it's a mess. It's sad. Everybody Chinese like that.
Okay. Any more observing reports or any other comments or questions?
Oh, and thank you for everyone who showed up for the estate sale too.
Yes.
Oh, yes.
Yeah, huge thanks to Sean and Ken for putting it. It was a great time.
Yes, thank you to Kent Blackwell for having that estate sale for Barry Farrell's equipment. It went fast. I got there at 11 and most of it was already gone. So I'm sure that the family appreciated that. And I know that a lot of astronomers got some good loot.
Yeah, some of them were here in this room.
Yeah,
Even Gabriel.
To say, well,
Yeah.
was it club members or were they?
yeah, I was there.
It was only open to astronomy clubs in the area.
Okay, so it was more than just our club.
Yeah, it was,
Oh,
yeah.
I have a question. The East Coast Star Party, is that more than just us?
No, that's.
That's just us.
Well, no, that's not just us. It's open to anybody in the area. We have people come down from Richmond. We
Well, I
have,
mean, we run it. but
we run it.
Everybody.
We run it, but it's
Anyone
open
can
to
go.
any astronomy enthusiast who wants to come.
Yeah, there'll be people from Richmond for sure.
Yeah.
Yeah, that's good.
Okay, well, we will move on to our meeting feature. And unfortunately, you guys out in Zoom land are going to be unable to participate.
I wish. I'll make all the pictures available for everybody too.
But Jeff is going to talk to us a little bit about Pluto. And I see somebody signed on as 471443. Who is that? I have no idea. We've got on the attendance sheet, we have 471443, whoever that is. Okay, Jeff.
Planet Pluto, bring it back.
Well, we're going to do some things today that they did in 1930, well, that Clyde Tombaugh did in 1930. And he was looking for something out there that was perturbing the orbit of Neptune, and he found Pluto. So why didn't they call it Tombaugh? Anybody know?
Didn't they have a contest or something to like a naming contest? And
Well,
so
they had a naming contest too. That's a 14-year-old, I think, won that one, but it was named after Percival Lowell, I understand, PL. And that's how they deemed it Pluto. And of course, it was one of the Norse gods or something. I don't know exactly. Norman?
Or named for-
Oh, Roman?
Pluto are named for Roman
Yeah.
gods.
Pluto.
Okay, well,
Pluto is the Roman god of the underworld.
I'm gonna show the camera so you guys can see in Zoom land what you're missing because you didn't come to a meeting. That's okay. You want to show them?
doing blink comparison.
Yeah, we're gonna blink a couple of slides here, and unfortunately, I can't show you in audience, or I have to walk around and make sure you do it because
Before for
the
asking.
document camera doesn't work.
Mine.
Oh, yeah. The document camera doesn't work. And I was hoping it would so we could show everybody. So I got these in numerical order, chronological order by date. So if you'll take a look at the July 29th and the July 30th, just look at those two for right now. And if you'll superimpose the stars, you can either do it by the light or however you want to do it. And you'll recognize some star patterns. You know, there's a big star with a couple of little ones, look like an isosceles triangle, and try to line those up as best you can. And pretend that this is 1930. They didn't have computers in 1930. In fact, they call the women that did space thing in 1969, they call them computers.
I think I see it.
You see it, okay. But the thing is, if you don't have a reference, how do you know which one it is? Which is it, the first sheet? Is it the second sheet? I see everybody. I'm going to take a picture of everybody. Wait a minute. Don't move. I got to take a picture. Everybody's
my neck.
everybody's looking at
My
you.
pillow.
I got to take a picture so I can show everybody. Because everybody's got you can't see it out there in Zoom land, but everybody's got their sheets up at the light, trying to figure out if they can line it up. Okay, I got everybody doing it. Okay, so once you get it lined up, try to keep the papers together as good as you can. And I'll do the same thing. And then put it down on the table. And you may have to move it, a millimeter or two. And you blink it back and forth. Let me show you out there in Zoom land what we're doing. We're blinking a couple of pictures back and forth, just like Clyde Tombaugh did, like this, And you can see the star patterns. But every now and then you'll see one star that pops in and pops out. So the answer, in case you're wondering, the solution for the first day, the 29th of July.
See it now.
You see it? Okay. So mark it. Okay, mark it on your. No, it's not on the bottom. Mark it on your sheet with a pencil. And I was going to bring some pencils today. I got one pencil here. Sorry.
I lost it. All right.
Now you lost it.
I got it.
And I can show you guys the answer to the first page. All right. Now you're correct on the first page. And you're correct on the second page. Very good. Very good. I've got the answer so far right here. Very good. Perfect. You guys are great. See, we're doing science too. Did you realize that? We're actually doing science.
It's just next to these two big ones. Right?
And they got, electronic waves.
Yeah, that was good. You draw
Right there.
through it.
Right there, right?
Um,
Is that little guy? Yeah.
is that the 29?
29.
Very good. Yep.
Yeah, that's it. And it goes to the right.
And the 30th?
It goes to the right.
Yep. So here's a question for everybody. Why is Pluto going to the right instead of going counterclockwise around the sun? Retrograde motion. We're going faster than Pluto. And Pluto's, I think it's almost at opposition, or maybe it's just past it, but we're passing, Pluto. We're going a lot faster than Pluto, so it looks like it's going backwards. It's in retrograde motion. Very good. All right, and you continue to do, say, we got 12 sheets to go through. So I won't bother you guys too much, but if you want to know the answer, I got the solutions right here for all 12 pages. And I can show you what I came up with. So I post these every now and then on the Facebook, and some people say, how do you know that's Pluto? How do you know that's Pluto? So I'm trying to show you this is how I figure out where Pluto is. Now I did picture of Ceres asteroid #1 Ceres, and it's as big as Texas. It's a big thing. And that's unmistakable. It's like 5th magnitude. Pluto is 14th magnitude. It's really, really a small dot. You can't tell which one it is. And these other stars around it are like 5th, 6th, 8th. But the last one, if you'll bear with me one more minute or so, the last 2 pages, that's the hardest. And if you want to do the next to the last 2, in other words, the last 3 pages, you can do that. That way, because there's one of them that's easy. I wrote easy on the 8th of September. I thought it was an easy one. And look, there's a lot more stars, a lot better exposure. That was an easy one for me. And I thought the toughest one was the last one, which had the most stars at Northwest River Park on the 28th. So to me, that was the hardest one. And there's a reason for it. If you guys can find it, you'll see why it's the hardest one.
It's a huge jump across.
That's a good point. From the 11th to the 28th is 17 days. So it moved more. So you'll notice that when you line up the pages, there's more of a gap between the pages and stuff.
This would be fun to cut it a little square into
Yeah.
a flip chart. Remember?
That's right. You really could. Yeah, absolutely.
Because it's hard to, rotate.
So I've got the last 2 pages here. I'm lining them up now.
Oh, I see why this one's so hard.
Yeah, you do? Now,
Yeah.
I don't want to say it. I want you guys to come up with it.
Yeah, I would have never, well, without blinking, I would have never done that one. I don't know
That's
why.
right. And it's the best image too. It's the best focus. It's the most stars, everything. It's the very best image. And if it wasn't such a good image, we wouldn't find it. And why Gabriel came up with that? Why was it so difficult?
Want me to say it?
Yeah, say it.
Well, if I'm, again, I might be wrong about this, but when I blinked it, they're like on the second page,
Mhm.
it looks like there's a very, very tight double star.
Right.
And then on the first page, it's not there. So, and it's like really, really close together.
Absolutely
like
right.
touching.
That's right. So it looks like there's a double star there. In the previous page, the double star is not there. I mean, it's a real tight double too. It's like they're almost touching each other.
Now I want to do a time lapse on this.
So I've got the last 2 pages. If you want to look at my answer key here,
Where do you start? Pretty center field, pretty much?
they're all supposed to be in the center.
They're all reasonably close.
They're pretty good. Yeah.
What the hell? Oh, these guys are way over here.
Now,
Oh, they moved a lot there.
on the
Oh my God.
28th, it's not in the center.
On the 20, I'm on.
It's left the center.
9/11. 9/11 is.
9/11, it's in the dead center. Well, pretty close to the dead center. So here's the answer to 9/11. I wanted to show you guys this on the screen.
Yeah.
That's 9/11.
Where's
Got a couple of arrows on it.
there amongst those 2 right there? Oh, I see it. It's a double.
Mhm.
Yeah, it's a double. Got it. And
And
where'd it
the
go
other
to?
one,
Where'd it go to? Did it overlap?
well, no,
They,
on the other one,
let's see, 9/11 versus, well,
on
9/28.
28, it's slightly left the center, and it's a real tight double.
28. And the little square.
Mhm.
Yeah.
Oh, well, wait a minute, no, that's not it. 28, those. That guy's there on the previous
Little
one.
smidge, but it's a double. It's a real tight double. That's what makes it so hard.
It's right there.
So what if a planet is covering a star, then you couldn't tell it's a planet?
No, it's right there.
I see where it
Because
goes.
it's, don't see where it goes.
9/28.
Yeah.
or something.
17 days. It's
All right, let me,
Show me the.
here's the 28. Looking at it upside down, we're at 28. Right there.
See, this is really.
There. Same place.
See how it
Yeah,
pops
that
out?
tights
Yeah,
up.
there's another star that's just popped out right there.
Yeah.
Look how tight that is. It looks like a double, it really looks like a double star.
It looks like a double on the 11th, right? 9/11?
I can't figure out where it is on the 11th. I can see where it's missing.
Yeah, I can see where 9/11 works, but I lose it. Where is it on 9/28?
There's my arrow. See my arrow? That's the 28.
I just can't figure out where it goes.
Right dead center.
Oh, it's not on top of it there. Okay.
Yeah,
Real
this
close.
is not.
So you didn't move, it didn't move much at all
It's not a
then.
document, but-
So double here.
Okay,
That's the 11.
that's the 11.
So it's piled on top of each other.
Section.
Here. It's the one it's next to the day before, right? Right on top of it. 1, 2, 3, yeah, right here.
My little arrow.
It's really well.
I see.
There's right there. So we got it.
Yeah.
Real tough, and
Oh, that jumped a lot then, okay.
it jumped a lot.
Oh, it jumped a lot,
What,
okay.
17 days? I forget.
Okay, there it is, now I see it, now I see it, yes,
Okay.
it's peeking out, okay.
So I ran these copies to my own printer. That's
It's sausage,
my
Jeff.
own.
It's a mental overload.
Strong because it's my heart. Welcome to a strong class.
We're
Professor
donating
Jeff
pictures.
teaching.
We need to do this every day so we don't go senile when we're older, right? Exercise the brain. Thank you,
Okay,
Jeff.
you're welcome.
Awesome. Seriously, the cool thing would be to align all these things and cut them so they're square and then staple and you go, you know.
Yeah.
That would be kind of cool.
Or to put it into a PowerPoint, perfectly aligned.
Boy, it's hard. I tried on PowerPoint and you gotta,
Be able to
you'll
rotate
fine
everything.
tune it
Yeah.
like this and it's really tough.
It's,
It might actually.
Talking about, that's what Tom Bow actually did, was he had them all aligned in a,
Oh, yeah, yeah.
like a cartoon.
Yep.
Oh, but that must
They
break
do
them up.
now with Ash and stuff. It's just digitally aligned, and then plays like a movie, and you can see it running.
Exactly right.
To do it in college.
Well, I thought maybe somebody would ask me a question about why are the exposures so different times?
Yeah.
Oh, I'm glad you asked. Great. So why are the exposures? Some of them are 20 minutes, some of them are 7 minutes.
Light pollution.
No, it's not just that. That has a big factor, but trees getting away, the clouds move in, and it stops. My sea star stops, not plate solving, but stacking. It stops stacking. And I'm looking at, and let's say it's 10 minutes and 40 seconds, and I'm watching it. 10 minutes and 40 seconds. The little thing's going around. 10 minutes and 40 seconds. 10 minutes. And I'm thinking, the heck's going on? I go out there and look, there's a tree in the way. That's why it stopped at 10 minutes and 40 seconds. Or a cloud. I go out and it clouds up and you can't see Pluto anymore. So
It disregards all the other ones. It stops.
yeah, it stopped, but it leaves you with the best stacking that it came up with, which is pretty good. All right. Well, I'm about done. So George has got some good stuff for you too.
Got a little bit of a presentation.
All right. And I'm gonna make these available. I'll post the link on Night Sky Network. I'll post it on tonight's meeting, and you can just click on the link. You can go and you get all these pictures for yourself if you want.
You get paid by C-Star.
No.
Awesome, Jeff.
I'm getting much better.
Very, very nice.
Okay.
I'm gonna get the new moon.
I think that was worth the mental gymnastics.
And you know there's a new moon out there.
It's supposed to be right?
Wednesday night. No, the new moon.
Okay. Let's see, where's that other one? Share.
Well, each one's pretty much. I mean, within a.
I had a screen up, but it's, oh, there it is. Okay. Here. This is what we'll start out with. This is size comparison. Most of you have seen this before, but if you haven't, this is a little refresher. This just shows us the comparison of the sizes of our planets in our solar system. Mercury is the smallest one. And of course, Mars. Venus is just slightly smaller than the Earth. And then the Earth, okay? Earth looks pretty big. And we always think of Earth as being pretty big. Let me move this over here. But then when we compare Earth with the other planets, Earth looks small compared to Neptune. Neptune is a little bit smaller than Uranus, and Uranus is way smaller than Saturn. Saturn, the gas giant, Neptune and Uranus, the ice giants. And then Jupiter is much smaller, much larger than Saturn. It would take 10 Earths to go across the diameter of Jupiter. Now you always tell people it takes 110 Earths to go across the sun. It would just take 11 Jupiters. But then Jupiter's small compared to the stars. Now we're starting to look at the stars. And there's a star, a red carbon star called Wolf 359, which is
Carbon star.
twice as big as Jupiter.
That's a tiny star.
That's a very tiny star because there's our sun. Our sun is huge. Like I said, it would take 10 of those Jupiters to go across the diameter of the sun. But the sun, I tell people, they think the sun is big. Well, sun is just a small star in comparison with the others. Sirius is the dog star, the brightest star in the sky in Canis Major. And Sirius is much bigger than the sun. But then Sirius is really not that big compared to some other stars. There's Sirius compared to Pollux. Remember Castor and Pollux, the Gemini twins? Well, Pollux is a very large orange or red giant, but small compared to Arcturus.
Oh, man.
I like to point out Arcturus in the sky because it's in the bottom of the constellation called Bootes, B-O-O with an umlaut over the second O, T-E-S, the herdsman. But I call it the ice cream cone because it's shaped like a V with a circular top, looks like an ice cream scoop on top.
That's not booties?
It's booties.
Booties. I was called the booties.
And the way to find Arcturus, I like to tell people, find the Big Dipper, and the handle of the Big Dipper makes an arc to Arcturus. Okay. Well, Arcturus is big, but Aldebaran is much bigger. Aldebaran is in the constellation Taurus the Bull. It's in the heart of the bull or the eye of the bull, depending on your imagination. So Aldebaran is a pretty big star, isn't it? Compared to Rigel, it's small. And Rigel is in the left foot of Orion. But he's small compared to the right shoulder of Orion, which is Betelgeuse or Betelgeuse. Okay, but then Betelgeuse isn't that much bigger than Antares. It's smaller. I mean, it's a little smaller than Antares. Antares is in the constellation Scorpius the Scorpion, and it's called Antares. Who knows why it's called Antares? I know Gabriel does.
It's something to do with Mars. It's like the antagonist of Mars.
The rival of Mars, because the Greek name for the red planet or the god of war is Ares, and Antares and the red planet are about the same color. Also, Antares is right near the ecliptic. So every 2 years, when Mars comes in its orbit around, it looks like it goes right past Antares, and you can hardly tell the difference in color.
I want to point something out here. If you get, being a stellar evolution, is kind of like one of my things. If you look at Aldebaran and Rigel, Aldebaran is an evolved star. It's in its giant phase, so it's already gone past hydrogen fusion, and is after they start fusing helium, they blow up. Aldebaran's blown up, but it was a small star that blew up. It's still smaller than Rigel. Rigel's a blue star. It's still fusing hydrogen. It's still in its adult life. When it starts to expand, when it can't do hydrogen anymore, it's going to start looking like Betelgeuse and Antares because it's a huge star.
They get
But
bigger.
it's bigger than Aldebaran, even though and Arcturus and all those guys, even though those are giant stars that have evolved. Rigel hasn't evolved yet. That's how big that sucker is.
Thank you, Rich. Well, compared to
Rigel is
it,
thousands of times brighter intrinsically than Sirius. Just Sirius is a lot closer to us.
Sirius is much closer. That's why it's the brightest star in the sky. Antares, we saw how big it was in the previous slide. Well, it's small compared to S Doradus, which is in the southern hemisphere, the constellation Dorado.
Asteroidus also not an evolved star. That is a main sequence star. It's about as big as they can get.
It's blue and it's still active.
So I think it's gonna be a beast.
So that's an interesting class of stars. It typically ends up being Wolf-Rayet stars because they blow off their outer atmospheres because they just are too big to maintain it. That's what happened to Eta Carinae. Eta Carinae was like Asteroidus, and then the Homunculus Nebula is just it got too big and it blew off its outer layers of hydrogen.
Okay, cool.
Okay, and then there's KY Cygni. Now, I don't know anything about this star. Do you, Rich?
Just
Looks like a
really big. I mean, it's an evolved supergiant, similar to Betelgeuse and all those. It's just bigger. But like guys like KY Cygni and VV Cephei, those are your likely supernova progenitors. So when we look at stars that are probably going to nova in our galaxy soon, those are the guys to look at.
When they originally supernova, they implode first, right? They implode.
Yeah. So what is physically happening with a supernova is stars evolved in these big stars, they start fusing heavier and heavier elements in their core. Eventually they get to iron, and iron cannot fuse because it takes more energy to fuse together. So what happens is there's a constant battle between the core and the outer
between gravity and the force pushing
gravity's trying to push it down, but the radiation pressure from the fusion is pushing out as radiation pressure, and that's what makes this nice stable star. So soon as these evolved stars fuse up to iron, they cannot fuse anymore. So now there's no more radiation going out to keep gravity at bay, and gravity slams down, and there's a big eruption afterwards. Now, theoretically, it should be possible for there not to be a nova explosion where all the mass of the star just collapses in on each other and you get a black hole with no explosion. There's actually been people trying to wonder why we actually see the explosion. But it has something to do with small imbalances and neutrinos get out, and that's why we actually see an explosion after the implosion. They call it bounce back. So it implodes, bounces back, there's a big explosion, and then you're left with a remnant, which is a black hole or a neutron star, depending on the initial size of the star that novaed.
Now, a few years ago, when I got into astronomy, VV Cephei, I was told that was the largest star. Well, let me show another picture of VV Cephei. VY Canis Majoris. I was told that was the largest star, the largest known star, VY Canis Majoris. Comparing it to VV Cephei, which was huge in the previous slide, it's very much bigger. But I've got another presentation to show you here. Let's see if I can, how do I get to it?
I think you shared just that. You're going to have to stop sharing, then reshare the other.
Yeah, that's right. Okay.
You're sharing Paul's right.
No, stop sharing that. Let me go to something we're just talking.
Yeah, share it from
Something we were just talking about, the life and death of stars. This is just a 5-minute presentation. It just
wait, don't play. You got to share it first.
Oh yeah, I got to share.
No, not that way. With Zoom.
Down at the bottom, Zoom.
Zoom. Yeah, there we are. Zoom meeting.
Now
Share.
Right.
And now we go to wherever I was. Right.
Left to left.
Yeah, life and death of stars. There you go.
And then share
at the bottom center. Blue button, bottom center.
Yeah. Oh, yeah, I was looking, where did you see life and death stars? I saw it. Okay, here we go. Let's,
Hello, everyone. My name is Keith Hawkins. I'm a postdoctoral research scientist here at Columbia University. My research focuses on stars and their evolution. And so the subject of this video will be a little bit about the life and death of stars like our sun. But before I get too far in, I want to remind everybody what a star actually is. A star is essentially a big hot ball of gas. But what makes it distinct from any old hot ball of gas is that deep inside of its core, it's undergoing nuclear fusion. Now, fusion is a process where you take 4 hydrogen atoms and you fuse them together into heavier elements. A star is essentially a tug of war between gravity trying to pull the star together and pressure trying to blow up the star and push it apart. The most familiar star to our own existence as human beings is probably the sun. But all of the stars in the night sky are similar to the sun and burning hydrogen to helium or heavier elements in their cores. So how is a star born? Stars are born from giant molecular clouds of gas. These clouds can be hundreds of thousands times the mass of our own sun. Over time, gravity begins to collapse this cloud and it heats up as it collapses. And when the gas gets hot enough, nuclear fusion will ignite, allowing hydrogen to fuse into helium. And this is the birth of a star. How a star evolves after this depends almost entirely on its mass. A star that's very low mass, about 8% times the mass of our own sun, is just big enough to begin fusing in its core. And we call these stars brown dwarfs or failed stars. Now, these can live for tens of billions of years, more than the age of our own universe, in fact. Now, a star like our sun, however, those will live about 10 billion years or so. The sun will spend 90% of its 10 billion year life happily fusing hydrogen into helium in its core. Now, since the sun is about 4.5 billion years old or so, or about just under halfway through its life, as our sun begins to die, its core will contract and heat up to fuse heavier elements, helium into carbon and nitrogen and oxygen. But its outer layers will expand, and unfortunately for the Earth, it will engulf the first 3 planets. So hopefully, in 5 billion years' time, when our sun begins to expand, we found a way off planet Earth. If we don't,
we're toast.
We'll be inside of our own sun. As it continues to evolve, the core will continue to fuse heavier and heavier elements. But when it reaches iron, it will begin to die. And the reason for this is because iron is a special element where you cannot fuse it to get energy out. And so fusion begins to turn off. The outer layers of our own sun will disperse away and become a beautiful planetary nebula like the one that you see behind me. At its center will remain the core of the sun, which we call a stellar remnant or white dwarf. Now, higher mass stars live even more energetic lives. These stars live only for about 10 or so million years. And most of their life, they fuse hydrogen into helium, but towards the end of their lives, they fuse all the other elements up to iron. When they reach iron, much like the sun, the nuclear fusion will begin to shut off. But because the star is so big and so massive, gravity will win the tug of war and send the outer layers of the star crashing down into its core. And this will be the start of a supernova explosion. These explosions are the most powerful and energetic explosions that we know of in our universe. Supernovas can be so bright that they shine more brightly than our own galaxy for days at a time. The other really cool thing about supernovas is that they disperse all of the ingredients for life that was formed inside of the star. Ingredients like carbon for our bones, oxygen that we breathe, iron for our blood. So when people say that we are stardust, they say this because when these stars die, these heavier stars explode and produce the elements for life and disperse into the universe. And the highest mass stars, the 50 or 100 solar mass stars, these stars become even denser and leave behind remnants like neutron stars or black holes. So regardless of if a star is very low mass, sun-like, or very, even very high mass, what it produces and its life cycle is exceedingly exciting. And still there are a lot of unsolved problems that maybe you can solve one day. about the life and death of stars. So if you're interested in stellar astronomy or anything that I've spoke about, feel free to look at the links below. If you're interested in the universe as a whole or just how things work, feel free to subscribe to our channel. We hope that you learned something about the life and death of stars, and we hope to see you next time.
Very nice. We'll give him a thumbs up.
He kind of missed on a couple
Turn
things.
that off. Oh, there we go. All right. Drink it back down. Okay, I got one more to go along with this. And this is, I was telling you about the large stars. This is the new largest star in the universe, WOHG 64.
On a clear, moonless night, above our heads, we can observe thousands of glistening stars. But that's just what we can see with the unaided eye. Observe the galaxy with powerful telescopes,
13.
billions more are revealed. In fact,
Well, it might
the
Omega.
Milky
Yeah, it's
Way
Omega
galaxy
Centauri.
alone is estimated to have between 100 to 400 billion stars. And look even further to our neighboring galaxies and beyond, there are an uncountable amount more.
Amazing.
The closest star to us, the Sun, appears enormous, the largest body in the solar system as it rises and sets every day. And although it dwarfs most things that come close to it, in reality, the Sun is just average sized. The universe boasts far larger stars that aren't just a little bit bigger, they are stunningly bigger. So how big is the largest star we have observed so far? How big can stars theoretically grow? And whatever happened to UY Scooty? You're watching V101 Space. My name's Rob, and if you enjoy my videos, then remember to subscribe, tap the notification bell to never miss an upload. When it comes to the largest stars in the known universe, it depends on whether we are talking about mass or total volume. Mass can be thought of as how much matter a star contains, whereas volume is how much space it takes up. The most massive stars tend to be quite unremarkable when it comes to sheer size, and the most voluminous stars often contain a lot less matter considering their physical size. As stars get older, they tend to lose their mass. This is something that is happening to the Sun as it grows in age, until eventually, in an estimated 5 billion years from now, after it has exhausted all of its nuclear fuel, it will evolve into a bloated red giant, engulfing the orbits of Mercury, Venus, and possibly even Earth. And although this process will make our Sun enormous, there are stars out there that come a lot bigger. Before we look at the largest by sheer physical size, let's look at the current largest by mass. Named BAT 99-98, this star is an estimated 226 times the mass of the Sun. That's 226 suns worth of matter all crammed into one. How this star became so massive isn't fully understood, but it may be the result of two stars that once merged together. Scientific models suggest that BAT 99-98 is only 7.5 million years old, making it extremely young when you think of the age of the Sun at 4.6 billion years old, and that it is also shedding its mass at a rapid rate. Since its birth, models suggest it has lost 20 suns worth of mass already. Because of how active it is thought that it will inevitably end its life in a catastrophic way, most likely a supernova that leaves behind a black hole. But although BAT 99-98 is extremely massive, it is nowhere near the largest by physical size, with an estimated radius of 37.5 times that of the Sun. It doesn't even come close. If you type into Google, what is the largest star in the universe, you will receive pages of websites telling you it is UY Scooty, a red supergiant that just a few years ago was considered the largest star by physical size ever observed. It was originally measured to be around 1,700 times the size of the Sun. However, it turns out that the distance of UY Scooty from Earth had been measured incorrectly. significantly altering its estimated radius to 775 times the size of the Sun, knocking it well and truly off that top spot. This new measurement actually puts UY Scuti closer in size to popular stars like Betelgeuse or Antares, still unbelievably enormous, but nowhere near the largest. In fact, it currently doesn't even make it into the top 80. So what about another star that was also believed to be the largest just a couple of years ago, named Stephenson 2-18, a possible red hypergiant star that was estimated to be so big if it was placed in our solar system, it would engulf the orbit of Saturn. And if you could travel around it at the speed of light, it would take almost 9 hours to complete one loop. In comparison, making the same trip around the Sun would take only 14.5 seconds. Some estimates put Stephenson 2-18 at being 2,150 times the radius of the Sun. But according to the stellar evolutionary theory, that might be problematic, because there could also be a theoretical limit to how big stars can apparently grow. According to the theory, the limit a star can grow is around 1,500 times the radius of the Sun. This could mean that Stephenson 2-18 has been overestimated, possibly due to its distance from Earth being uncertain by as much as 50%, which, like UY Scuti, would significantly alter its estimated size. But then again, as far as I could find, there is no clear-cut equation that determines how big a star can grow, since it depends not only on mass, but composition, evolutionary history, and the strength of its stellar wind. For potential giant stars, such as Stephenson 2-18, the outer atmosphere can in theory continue to puff up and grow essentially without limit. However, at some point, the diffuse gas of its outer layers becomes merged with the interstellar medium and cannot really be regarded as the stellar surface. So when it comes to measuring the size of a gigantic star, it turns out that it's no easy task. These objects are, of course, extremely big, thousands to millions of times the volume of the Sun, are extremely far away, and are extremely luminous. And as I just mentioned, they also tend to have far-extending atmospheres and photospheres that are ever-changing and are often shrouded in enormous clouds of dust, making their true size very difficult to discover. Nonetheless, astronomers attempt this by using a range of different factors, such as the distance and the environment around a star. By discovering these measurements, among other things, they can more or less get estimates that fall within a smaller or larger area of confidence. So based on our best measurements, what is the current largest star in the known universe? Well, according to the list of largest stars known, that title is currently held by a red supergiant called WOH G64. A star located around 160,000 light-years away in a neighboring satellite galaxy called the Large Magellanic Cloud. WOH G64 has an estimated radius of 1,540 times that of the Sun, meaning that if it took the place of the Sun in the solar system, it would engulf the orbits of Mercury, Venus, Earth, Mars, and even Jupiter. This measured radius also fits in nicely with that theoretical growth limit and is consistent with many other large red supergiants found elsewhere. WOH G64 is likely in the latter stages of its stellar evolution. These types of stars have exhausted their nuclear fuel, leading to the expansion of their outer layers, transforming them into true cosmic giants. The enormous star is also shrouded in a torus-shaped cloud of dust about a light-year in diameter, which consists of material it has expelled. Incredibly, it is estimated that if all the material in the Taurus cloud was collected, it would be enough to make our entire solar system 9 times over. So have we finally cracked it? Is WOHG64 the largest star in the known universe? Well, probably not, because there have been other studies that have also measured this behemoth and got a completely different measurement. Although one source did put it at 2,575 times the radius of the sun, making it far bigger than even Stevenson 2-18's possibly overestimated size. If this is correct, then it would easily engulf Saturn's orbit, and if you could once again travel around it at the speed of light, it would take almost 10.5 hours to complete one loop. In comparison, light from the sun travels to Pluto in only 4 hours. So, although it is clear that the universe is full of some truly enormous stars at different stages in their evolution, until we can gather more accurate measurements, which one is the overall largest isn't clear. However, with ongoing advancements in observational techniques and technology, astronomers will be able to refine their measurements and so understand these cosmic behemoths far better. WOHG64 could well be the largest star ever observed in the known universe, but something tells me that top spot will change again. I really hope you enjoyed this video. If you did, then please tap the like button and subscribe. Thank you for watching, and I'll see you next time.
I thought that was interesting. And it goes along with our study of T Corona Borealis, watching to see if it's going to explode or when it's going to explode. So is there anything additional or any questions or comments you want to add?
I have something here. I'm gonna, most of I don't have anymore. Originally came with this red dot finder, which I cleaned to work and used my vast knowledge of electricity. I changed the battery and switched it around and see if that was a problem. Anybody would care to take a try at it and see if they can get it to work, and then the club can have it. And Sean, I have to notice there's a couple of extra brackets in here for different telescopes for the red spot finder if you want.
Okay.
Anybody want to give it a try and see if they can fix it? This bracket. Hmm? Yeah. Like I said, if anybody wants to try to play with it, or know anybody who play with it,
You change the battery?
I changed the batteries, I turned the batteries around, I did this, I did that.
So it's an LED type,
Yeah, it's red.
LED?
Round thing that goes in there, took out the original battery, bought a new one just
Thanks.
like it.
I'm sharing.
So if anybody wants to give it a try, see if they get it to work.
Sean's holding the rest of the stuff. Send it over to him.
You know, you turn it down, please.
I could probably fix that.
Hmm?
I could probably fix that.
Okay,
It's probably just a loose wire.
well, there you go. And if that's the case, then the film has another finder.
Cool.
Okay, well, thank you.
I got rid of that now.
And that's nostalgic because Orion's no longer.
Anything else we want to talk about? I do have, oh, thank you for reminding me. It's time
Want
for
that
the,
George library book.
time for the drawing, the Deep Sky Observer's Year. Everybody got a red ticket?
Odds are really good tonight, right?
Rich, Roland, did you get a ticket? No, you didn't.
Gotta be here, Rich.
Have them pull the ticket.
Yeah, have Rich pull a ticket.
Must be present to win.
All right, come
All
on.
right, here we go. I'm gonna pull my
I
own
want a piece
ticket.
of George's library.
Okay, the winner is 3671925.
Piece of George's library. Not
autographed though. I didn't autograph.
He gets a red dot finder and a George library book. King.
Nice.
Okay,
Meeting.
thank you, everybody. I think that was a good meeting. We're adjourning a little bit early at 8:45. Meeting adjourned.